Hi guys. So very similar to Tuesday, we are going to look at a concept that you have seen many times this year and just apply it to a new function. And that concept is inverses. So you have done inverses several times this year. So the way you find them has not changed. To find an inverse, you still switch x and y. We're just going to look at inverses for log and exponential instead this time. As we talked about before, log and exponential functions are inverses of each other. But now we're going to just show it algebraically and get some extra graphing practice in. So we'll start in this first one. So to find that inverse, I'm going to switch x and y. So x equals 11 to the y plus 1 minus 4. So add 4. And then at this point, in order to get y by itself, I would have to rewrite this as a log. The base of the exponent becomes the base of the log. So this would be log base 11 of x plus 4 is equal to y plus 1. Then my last step would be to subtract 1. And I'm going to go ahead and write it as the right notation, f inverse of x. All right, looking at the next one. Again, same thing. Switch x and y. We'll start by dividing by 2. And I'm going to write it as 1/2 x just because if you were to graph this, that might make it a little easier. There's nothing wrong with writing that as x divided by 2. It's still the same thing. So now, in order to get y by itself, since it's in the argument, I have to rewrite this in exponential form. So base is e to the 1/2 x power is equal to y plus 6. Subtract 6, and you've got your answer. So that's algebraically how we're going to find inverses. Again, if you've understood those solving questions from last week, that really won't be that bad because we've done inverses again so many times this year, and it's really just the switching the x and the y. So what we're going to do now, same thing. We're going to find the inverse algebraically. We're also going to get some extra graphing practice in, though, and actually graph these equations. So I'm going to start by finding the inverse algebraically, and then we'll go back and graph. So we'll do x equals 1/2 log of base 2 negative x minus 2 plus 3. Oops, sorry. That should be a y. So I'm going to start by subtracting 3. Multiplying by 2. I'm going to leave it factored out just because, again, that'll make it a little bit easier when I get to the graphing part. And then at this point, I can rewrite this in exponential form. So I would rewrite this as 2 to the 2x minus 3 power is equal to negative y minus 2. Next step would be to add 2, and that's equal to a negative y now. So now I need to multiply everything by negative 1. Again, I need to be careful. I can't just stick a negative out in front here. I am making the entire function that I have negative. So I either need to distribute that or I need to put some parentheses there. And I'm going to go ahead and distribute it because that'll make it easier to graph. So a lot of 2's in that problem. So now let's actually graph this. So I'm going to start by graphing the log equation. All right, so again, I'm going to factor out that negative. So I'm going to rewrite this as negative x plus 2. So the log function has a base of 2. It's shifted left 2 and up 3. So all of my points that I write are going to be in relation to the point negative 2, 3. So negative 2, 3 is my log little new origin. It has a vertical asymptote at that point. So log's pattern was 1, 0, base 1, base squared 2, 1 over the base, negative 1. This graph has 2 other transformations to include. It's got that reflection over the y, which is going to make those negative. It also has that vertical compression, which is going to change those values. So from my new origin, then I'm going to be going left 1 and up 0, left 2 and up 1/2, left 4 and up 1, and left 1/2 down 1/2. All right, so now let's look at our exponential function. So that exponential function has gone right 3 and down 2. So my table here is going to be in relation to the point 3, negative 2. So 3, negative 2, since it's exponential, it's going to have a horizontal asymptote. All right, exponential is 0, 1, 1 comma base, 2 comma base squared, and negative 1, 1 over the base. This function has a reflection over the x-axis. And this function has a horizontal compression by 1/2. So from that new point, over 0 down 1, over 1/2 down 2, over 1 down 4, and then left 1/2 down 1/2. And there's my exponential function. So by looking at this, one of the things I want you guys to see is just looking at that curve, it's kind of hard to tell which one's log and which one's exponential if you don't have that asymptote there. That's why that asymptote's really helpful for you to understand which equation you have when you're looking at these together. All right, so again, let me just label this is the inverse and this is the original. All right, we're going to try one more like this. So again, we're going to solve algebraically to find the inverse first, and then we're going to graph both of them. So let's start by solving algebraically. Switch x and y. Subtract 4. Divide by negative 1/2, and I'm just going to leave it out in front because that'll make it easier when I get to the graphing point. It's not wrong to write it as divided by negative 2, but again, this will just make it a little easier when we get to graphing. So at this point, I need to rewrite this as a log. So the base of the exponent becomes the base of the log. And then my last step is just to add 1. All right, so then at this point, we'll go ahead and graph these. I'll start with the exponential function. So the exponential function has a base of 3. Again, the 3 is not a transformation. The 3 is just the base. It's gone right 1 and up 4. So right 1 up 4 is my new origin for exponential. Since it's exponential, it has a horizontal asymptote. So in relation to that point, I'm going over 0 up 1, over 1 up the base, 2 base squared, negative 1, 1 over the base. The only additional thing I need to consider is this negative 2. That's a reflection across the x, and that's a vertical stretch. So I'm going to multiply these values by negative 2. So from that point, over 0 down 2, over 1 down 6, and then the other one's going to be off my graph, and then I've got negative 1, and that should be 1/6. I don't know why that looks like 16. Sorry, that actually is multiplying by 2. That's a negative 2/3. There we go. And there's my exponential function. All right, we'll go ahead and graph our log graph. Base is 3 again. It's gone right 4 and up 1. So right 4 up 1 is my new origin. We've got a vertical asymptote. So in relation to that 4, 1 point, I'm going to go right 1 up 0, base 1, base squared 2, 1 over the base, negative 1. The transformations for this graph, it's a reflection over the y and a horizontal stretch. So reflection over the y and horizontal stretch. So we're going to take these and multiply by negative 2. So from that new origin, left 2 up 0, left 6 up 1, and then left 2/3 down 1, kind of hard to see on my graph, but good to have on there. And there's my inverse. There's the inverse. There's the original. Again, one thing you'll notice about these graphs, remember x and y's flip. So this point goes through 1, 2. The inverse goes through 2, 1. This one goes through 2, negative 2. Negative 2, 2 is on the inverse. So those x and y's are flipped. Those graphs are also reflections over the line, y equals x. All right, so the last thing we're going to do is what we've done again for every function so far. We are just going to write those transformations. Again, pay attention to the order. That's really the only part that can get kind of tricky. So we have the function natural log of x. It's gone left 2 and up 3, and then it's been vertically stretched. So we'll start with these first two transformations. Left 2 and up 3. So left 2 is f of x plus 2. Up 3 is plus 3. So I'm taking the natural log of x. F of x plus 2 would become the natural log of x plus 2. Up 3 would be a plus 3 on the outside. After that's happened, okay, that's happened, that's done. Once that's done, we are then doing a vertical stretch by a factor of 2. So I'm taking this function and multiplying it by 2. I'm doing 2 times the f of x function I just had. So I either need to have those parentheses there, or I could just rewrite that as 2 natural log of x plus 2 plus 6. All right, and then looking at this last one, same idea but exponential, just to review. So right 5 and down 2. Again, right 5 would be f of x minus 5. Down 2 would be minus 2. So f of x minus 5, that's going to be in the exponent. Minus 2 is going to be away from it. After that is done, it is followed by a reflection over the x-axis. So again, I am doing a negative f of x. So I am making the function that I have negative, which means my new function is negative e to the x minus 5 plus 2. All right, so that is it for your inverses. Again, a lot of familiar stuff that you guys have seen, really some extra graphing practice as well. So again, there was no Edpuzzle, as you've already seen. Work your practice problems, check your answers, show your work, especially on those inverses. You really got to show the algebra to find that. If you need help, you can email me, do that video request, or you can jump in the Zoom session for Thursday. If you need that Friday Zoom session, then just send me an email so we can make sure we're ready for it. Then you've got your week 7 assessment by Friday. All right, if you guys have questions, then feel free to reach out.